Welcome to part 5, data types. This is chapter 1, integer, float, and Boolean data types. We're now going to begin deeper coverage of all of the pandas data types. We've touched on them before, but now we're just going to learn much more about each of those types, how they're converted from one type to another, which types exist, and so forth. So by the end of this part, you'll have a very firm base on all of the possible data types in pandas. All right, so we're going to begin here, something not directly with data types, but by learning how to construct a series by hand using the pd.series constructor. So as you've seen in all of the previous work so far, our series have been selected as a single column of a pandas data frame. That's typically what is done. You read in some data, and we've done that with the read CSV function, and then just selected a single column of data. But you can also create a series like this using its constructor. This is typically not done. You don't typically create a series by hand, which is why I haven't not shown it before. But I'm going to create one, and the way you do so is you use the series constructor. You pass it in a list of values. There's actually multiple ways, but this is just one of the ways to create a series. So here we're going to create a 3-item series, or a series with 3 values like this. And these are integers. I'm going to assign it to sint, and then it will output it to the screen like that. All right, so I have a simple series over here. This is just to show you how the data types work in pandas, which is why we're creating a series and not using actual data. All right, so we know the D type over here is int64. We can get that with the D type attribute. So what exactly does this int64 mean? Well, it stands for a 64-bit integer. All of these data types are from NumPy. So pandas uses NumPy underneath for many of its data types. No, not all. Pandas has many unique data types that we'll learn about in a little bit. So what exactly does a 64-bit data type mean? Well, it means we can store 64 bits of information. Every bit can store 2 numbers. So if we want to, we can actually use this to calculate the total number of possible integers that are possible to be stored within int64, right? You can't store every single possible integer with 64 bits of memory. What you can do, if we raise 2 to the 64, is store this many numbers. And if we divide this in 2, like this, this is the number of numbers to the left and to the right. Right, so you get to consider negative numbers as well as positive numbers. And we can verify this using the NumPy's IInfo function. So we can import NumPy as MP and then call the IInfo function and pass it a string name of the data type. So here we put in int64, and you can see over here, here's the minimum integer, and here's the maximum integer. It is 1 less than the minimum. That's just because it includes 0. But altogether, there are this many numbers that are available, integers that are available to be stored. So if you have an integer that is larger than here, you cannot store it as a 64-bit integer. Same thing if you have an integer less than this minimum, then you will not be able to store it either. So NumPy has an 8-bit integer, so 2 to the 8. So that's 256 possible numbers. Right, so from negative 128 all the way to 127, that's 256. You can see 16 right there, also 32. You might be wondering why, if there's a int2, but there's no 2-bit integer. The minimum number of bits that modern computers can address is 1 byte, which is 8 bits. So, which is why int8 is the smallest available integer that you can use. All right, so that's a little bit more on just a basic series and its integer int64 data type.